Audra? What type of energy changed our thinking about the law of conservation of energy, which originally said that energy can neither be created nor destroyed, simply change from one form to another? So solar energy to electrical energy to mechanical energy to thermal energy. What type of energy did we develop that actually changed all of that? If you listen to the last question, it would tie in. You can do group, guys. Sammy, she said group. You're not, Sam, you don't know it? You don't know it? Because Audra called group. It doesn't matter. You want to listen to every question. The question is, you know, Joe, I'm not so sure this is going to work well because I think some people are not paying attention. If you were writing it down, maybe pay more. You guys will tell me next week, next time we have a test, to see if this method works better or not. The question is, what type of energy did we develop that defied the law of conservation of energy, which says that that energy can neither be created nor destroyed, just change from one form to another? And you would be right. Atomic energy. Atomic energy, nuclear energy, fission reactions, fusion reactions. Okay. Oh, that was the whole Manhattan Project, developing a new bomb that created enormous amounts of energy. Where'd that energy come from? Literally destroying matter and putting in its place energy. Andrew, when you have an atom that has either given up electrons to make its outer ring stable or accepted electrons to make its outer ring stable, we now have the atom is now called, an atom with a charge is now called comes over here back to Sammy. Group. An atom with a charge. And it's one of the forms of bonding. You're supposed to discuss it, not just throw it out, but no. So we're back over here, and it is to Amr. I didn't ask for the bond. I asked for the atom with the charge, and that is called an ion. Ions come together in ionic bonds. Now, Austin, in what type of bonding, which is a very strong bond, do atoms actually share electrons? Five, four. Now it's covalent. You say it often enough, it'll be the right answer. Covalent bonding. The third kind of bonding, Andrew, is the kind of bonding that you see in the DNA double helix, which we'll get to when we do genetics. And that's a pretty weak bond. Excellent. Nicely done, sir. You actually have your notes from the other day. Hydrogen, covalent, and ionic. Water is an interesting compound Give me one of the reasons that it's so critical, Roy. It has a pH of 7, well said, which means that it's neutral. Jordan, give me something else. Five, 4, 3, 2, 1. Sorry. Not funny? That's a little sad, girls. Brandon, give me something else, please. All you'd have to do is look at the map and have an idea. Brandon? 5, 4, 3. It is the most abundant compound. Thank you very much. So, it is water. It is the only material that's neutral. It is the most abundant compound. You already have this in your notes. It is the universal solvent. It has a high... What is the term? What is the term that means the ability of a material to get hot and retain the heat? This is over here at Hannah. Margot, what is the term that means a material's ability to get hot and retain the heat? And water has a high one of these. Has a high specific heat. Okay. Water is a polar molecule. Polar molecules have a little higher charge on one side than on the other. So one side's a little positive, one side's a little negative. And polar molecules dissolve other polar molecules. Once I tell you that, what can you tell me about oil as far as being polar or nonpolar? Water is